The second half of 7.4 is about applications of logarithms. So there are 3 problem types that are in this section for applications. The first one is the pH scale, the second one is the Richter scale, which is for earthquakes, and the third one is for decibels, which is measuring sound intensity. Now, because these are log scales, a 1 unit increase means that it's 10 times as strong, or E times if you were having to use natural logarithm. All of these use the common log. So the thing we raise to a power is 10. Alright, so a pH 3 to 4 means you have 10 times the ion concentration. A Richter scale 4 earthquake to a Richter scale 6 earthquake means, so that's 2 jumps. So that's 10 times 10, which is 100 times as strong. So why would we want to use a log scale? Well, you would use a log scale if you are working with exponential growth, right? Because exponential and logarithms are inverses. So if you have exponential growth, you might want to use a log scale. If you have a really wide range of values, then you might use a log scale to kind of decrease how spread out your data is. Or if you want to show growth as multiples, like orders of magnitude, there might be a reason that you want to do that specifically. So in the case of pH, we're measuring a concentration of ions, so that's a really wide range of data. So for that reason, using log scale is good. Like you could have 10 to the negative 1 for a pH or for an ion concentration, but all the way up to like 10 to the 15. So that's so wide that using a log is going to make it more manageable. For an earthquake, definitely that is a type that you'd want to show like growth as multiples, so it's 10 times 100 times as strong. Same thing with decibels. So with decibels, it's kind of a combo of the two. It's a really wide range that we have in terms of intensities that we can hear. So a log scale is useful, and also it's useful to be able to talk about something is multiples of 10 times stronger. Individual like small steps in decibels you can't really detect in your ear, but it's easy for you to tell, large changes, these multiple changes. So that's why a log scale might be useful there. If you do have something that's exponential growth and you use a log scale on it, because the log and the exponential are inverses, you're going to get something that looks linear. So actually using a log scale with exponential growth is an easy way to, or what you think is exponential growth, is an easy way to see whether or not it really is exponential. If you think it's exponential and you plot it on a log scale and it turns out linear, guess what? It actually is exponential. So lots of reasons that we would want to use these log scales.